evoked earlier, logical agents needs a knowledge base. This is a set of sentences in a formal representation called logic. Logics are of different forms and are formal languages for representing knowledge to extract or to derive other conclusions. It requires two main components. One is called the syntax. It's actually the component that defines well-formed sentences in the language. And it requires a second component, which is semantic, which defines the truth or the meaning of the sentences in a word. We use inference, which is a procedure to derive a new sentence from another one. This requires using only the syntax. And we use logical entailments in terms of semantics, which is a relationship between sentences. It means that a sentence logically follows logically from another one. And we would write that, for example, that the sentence alpha follows logically from the knowledge base. In this lecture, we will focus on propositional logic, which is the simplest logic. The syntax of propositional logic defines the allowable sentences or propositions. What is a proposition? It is a declarative statement or sentence that's either true or false. So this defines what's a proposition. We distinguish between two kinds of propositions, atomic propositions and compound or complex propositions. An atomic proposition is a single proposition or symbol. The notation usually we like to use uppercase letters combined with some subscript to represent those propositions. A compound proposition is constructed from atomic propositions using parentheses and also logical connectives. Okay, so logical connectives represent an important way to combine simple propositions or atomic propositions to make larger ones. Here are a few examples of atomic propositions. 2 + 2 = 4 is a true proposition. W13, where W represents WAMPUS and 13 represent the room, column, and line, is a proposition. It is true if there is a WAMPUS in 13 and false otherwise. If there is a stench in 12, then there is a WAMPUS in 13 is another proposition. It's a conditional. How are you and hello are not propositions. In general, anything that is a statement or question or comment or opinion is not a proposition. Example of compound or complex propositions are as follows. Suppose we have P1 and P2 propositions. The negation of a proposition, noted as negation of P, is also a proposition. We call in propositional logic a literal either an atomic proposition or its negation. We call, for example, W13 as a positive literal, and we call negation of W13 as a negative literal. But both of them are a compound proposition because they are the negation of another atomic proposition. The conjunction is when you put atomic proposition together with the conjunction. So if we have P1 and P2, it's the conjunction of both propositions P1 and P2. For example, there is a WAMPUS in 13 and there is a PEAT in 3.1 is a conjunction between the fact that there is a WAMPUS in 13 and 3.1. So if there is truly WAMPUS in 13 and there is a PEAT in 3.1, then the conjunction of this proposition is true. This junction is P1 or P2. So just putting the or between the two propositions. For example, there is a WAMPUS in 13 or there is the PEAT in 3.1. The implication is P1 implies P2. So we use this symbol. For example, there is a WAMPUS in 13 and there is a PEAT in 3.1 implies that there is no WAMPUS in 2.2. So we are going, here we are using a composition of different propositions through the implication and the conjunction. And we also have the negation for this term here, or for this atomic proposition. Finally, if and only if, P1 if and only if P2 means that actually we have P1 true if and only if P2 is true. For example, W13, there is a WAMPUS in 13 if and only if there is no WAMPUS in 2.2. So we are able with this connectives actually to build larger and more complex propositions to express interesting facts about the word. So how about the semantics? The semantics define the rules to determine the truth of a sentence. Semantics can be specified in propositional logic by what we call truth tables. These are very important ingredient in propositional logic, in which we have a table of true and false. This is the domain. A table is a set of n tuples. These n tuples have n values, and these n values are in true or false. We also define an operator on the n tuples. It's called G, that actually outputs a Boolean value for combinations of truth or true and false for the possible propositions. Then a definition for truth table is an operator G on the n tuples by specifying one Boolean value for each tuple. The number of rows in the truth table is 2 to the n, where n is the number of atomic propositions.